Moving an organization's infrastructure to the cloud relocates physical assets and redraws the defensive perimeter and operational reality. The exact migration path an enterprise chooses dictates what security controls can be applied, when they get applied, and who is ultimately responsible for maintaining them. To structure these paths, architects use the 6R framework, a methodology that categorizes 6 distinct migration strategies. The 6R framework maps along a transformation spectrum, from minimal architectural changes on the left to complete system redesign on the right. This dual-axis graph shows the central tension. Less code change inherits legacy risk, while more transformation introduces cloud-native threat surfaces. This selection process determines the future security ceiling of the application. An ill-fitting strategy can result in a security posture inferior to the original on-premises environment. The most basic strategy is REHOST, or lift and shift. Workloads move directly to cloud virtual machines with zero code changes. Because the code is untouched, existing software vulnerabilities and deferred OS patches travel intact to the new cloud environment. This creates an immediate network risk. Default cloud networks often assign public IP addresses automatically, meaning a previously isolated internal server can easily be exposed to the open internet. To prevent exposure, engineers configure cloud security groups to precisely replicate the old on-premises firewall rules. They also have to add cloud-specific default protections. A primary example is actively blocking the Instance Metadata Service, or IMDS, from untrusted roles, so attackers cannot extract cloud credentials from the migrated machine. Despite the carried risks, rehosting is heavily utilized for legacy systems facing tight data center exit deadlines or for establishing rapid disaster recovery environments. It prioritizes migration speed, but requires accepting the technical debt of carrying legacy threat services directly into a hyper-connected public cloud environment. Moving to the right, we find REPLATFORM, or lift, tinker, and shift. Here, the application moves to cloud infrastructure with minor optimizations, like swapping a self-managed database for a managed platform like Amazon RDS. This shifts the shared responsibility model. The cloud provider now takes over the patch management and maintenance of that specific managed component. However, this introduces the risk of configuration drift. The managed service comes with its own default security posture, which may fail to match strict organizational policies. And during the actual data migration phase, strict encryption in transit is mandatory to prevent interception while moving records into the new managed service. Further along the spectrum is repurchase, or drop and chop. This is the decision to completely abandon an existing on-premises application and replace it with a third-party software-as-a-service equivalent. The primary security trade-off is control. Data ownership transfers directly into the SaaS provider's shared multi-tenant infrastructure. Because the data now lives externally, centralized single sign-on integration is absolutely mandatory to maintain identity governance over the platform. Organizations also see a post-migration increase in shadow IT as users realize how easily they can onboard additional unauthorized SaaS tools. Furthermore, SaaS adoption must be immediately cross-referenced with regional data residency laws, specifically the DPDP Act 2023, to ensure the data is legally processed. Moving to SaaS offloads infrastructure patching, but weakens the organization's direct control over data localization and configuration drift. At the far right of the spectrum sits refactor, or re-architect. This requires the complete redesign of a monolithic application into a cloud-native microservices architecture. This high-effort approach is the primary way to achieve security by design, enabling engineers to execute threat modeling directly at the architecture phase. The crucial security metric here is isolation. Every individual microservice requires its own dedicated IAM role and distinct network policy. With the monolith broken down, the primary vulnerability focus shifts toward container image security and rigorous verification of the software supply chain. This necessitates the principle of DevSecOps and the need to shift left. Security checks are no longer done at the end of development. They are shifted backward into the code writing process itself. Automated testing tools like static application security testing, like dynamic analysis and software composition analysis, must become standard within the deployment pipeline. This requires massive upfront time and engineering effort, but the long-term payoff is unmatched agility and security. A well-executed refactor creates a highly resilient system. Because the components are strictly isolated, a breach in one microservice is contained locally, preventing it from compromising the entire application. Refactoring demands significant organizational effort, yet it provides the most granular level of control for achieving a cloud-native security posture. The final two strategies of the 6R framework sit completely outside the main spectrum because they require no cloud migration at all. Retire is the complete decommissioning of an application that is no longer useful. But deletion is highly regulated, mandating strict data sanitization protocols to comply with the DPDP Act 2023. It also involves critical administrative security tasks, requiring strict software license revocation and credential deprovisioning. The sixth strategy is retain. This is the conscious decision to leave workloads on premises due to regulatory rules, legacy hardware constraints, or complex licensing. Retained workloads rarely exist in a vacuum. They connect to newly migrated cloud systems, forming a hybrid environment linked by a secure VPN tunnel. This connection establishes a critical threat surface, requiring heavy encryption and monitoring. The decision to delete a system or keep it on premises requires as much rigorous security protocol and audit logging as a full cloud migration. Evaluating these strategies on technical merit alone is insufficient for a regulated enterprise, as sovereign data laws often override technical preference. This chart breaks down India's MIT Cloud Policy 2023. It imposes a strict three-tier workload classification for government and critical data. The top tier, Megraj, is explicitly mandated for hosting and processing the most sensitive sovereign data. This regulatory classification wholly supersedes an organization's technical preference for any of the 6R strategies. For example, if an agency attempts to rehost critical citizen data to an international commercial zone, the data hits a legal wall. The policy renders it illegal, forcing a hard redirection to the national cloud. When evaluating a migration path, legal compliance acts as a permanent filter over the entire strategic spectrum. Data sovereignty, shared responsibility, and architectural determinism form the actual boundaries of a successful cloud migration.